long story short, I'm kind of an idiot, and I didn't check to see whether or not the video had uploaded before I deleted it this morning, thinking, of course, I uploaded it last night, it should be good. And so it was super slow, and then it was no longer recording or uploading because I deleted it. So I'm gonna do it again. Okay. I'm gonna do the odd problem, so I'm gonna go ahead and start with number 1. Let's see. Okay. So number 1, we've got 4 cosine cubed times sine equals sine of 2x times 1 plus cosine of 2x. Okay. So, well, actually, give me a second. Sorry, there was a fan going in my house, and I want to make sure that it didn't make it hard to hear me. Okay. So, first off, when I look at this problem and I think which side do I want to work, I'm almost always going to choose to replace the double angles and the double angle expressions because this is the easier goal for me to get to as opposed to trying to get to something and then recognize it as sine of 2x or recognize it as this. So what I'm going to do is I'm going to use my identity. I'm going to go right to left. And I know that sine 2x, the double angle, is 2 sine cosine. So sine 2x is 2 sine cosine. And then 1 plus cosine 2x, so this right here is going to be very useful if you can train yourself to see this. 1 plus cosine 2x is in the power reducing. If I were to multiply both sides by 2, or multiply this 2 over there, 2 cosine squared equals 1 plus cosine 2x. So I'm going to replace all of that with 2 cosine squared. 2 times 2 is 4. Sine times, well, there's just one sine. And then cosine times cosine squared is cosine cubed. And multiplication is commutative, so we are done. Okay. Let's go on to number 3. So number 3 says cosine times 1 minus tangent squared equals cosine 2x divided by cosine x. Okay, so like I just said, I tend to prefer to replace the double angles and whatnot. I might end up playing around with both of the sides to see what I can get, but I'm going to try and see if I can go straight from right to left without messing with that. So let's look at this. Cosine 2x. Now cosine 2x, I've actually got 3 options. Cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. I do have a cosine over here in the numerator, and I have a tangent, which is sine squared over cosine squared. So I'm just going to go with the first one. Cosine squared minus sine squared all over cosine. Okay. So when I look at this and I look at what I need to get a 1 minus tangent squared. So I could see a lot of people going ahead and simplifying this, but I think what I want to do is I want to think about how am I going to get a tangent squared, right? So a tangent squared is a sine squared over a cosine squared, and I see that I have a sine squared over a cosine, but I don't have a sine squared over a cosine squared. So as a trick, what I think I'm going to do is multiply the top and the bottom by cosine. And then I'm going to see what I need. Okay, so over here, I've got a single cosine in the numerator. Okay, so that's my cosine, so I'm going to go ahead and just rewrite that one. So that's that. This right here is cosine squared, so I'm going to rewrite this as times cosine squared minus sine squared, all divided by cosine squared. But what I'm going to do is I'm going to split it up. So if you keep in mind that if I asked you to multiply 3 times 4 over 5, that's the same thing as saying 3 times 4/5. So I can move the 5 to just the denominator of 4, and that's what we're going to do here. So I'm going to have cosine times, and then the fraction cosine squared minus sine squared, all divided by cosine squared. And then when I have a fraction like this, I can actually split it up and say, well, that's the same thing as saying cosine squared divided by cosine squared minus sine squared divided by cosine squared. And that right there is 1. And that right there is tangent squared. And then I'm done. That is definitely one way to work this problem. It's not the only way. I'm going to kind of play around with it maybe. If I had done, I'm going to rewrite it and see what all the things that we could have done. Okay, so I could have said cosine times 1 minus sine squared over cosine squared and distributed my cosine and said cosine minus and then said sine squared over just cosine. Yeah? And then I could have said, well, if I do a common denominator and say cosine times cosine, then I get cosine squared minus sine squared over the common denominator cosine, and cosine squared minus sine squared is cosine 2x. Now that one just kind of fell into my lap because if, like I wasn't necessarily keeping this goal in mind, I was just seeing what happened, and then because I recognized that as cosine 2x, I knew I was done. It's just kind of whatever you see. Now, say I hadn't done the common denominator, but then I had also worked this side and said, cosine squared minus sine squared. I was trying to play around with it, so I did both sides, right? And then I divided, and I said this divided by this is cosine, and this divided by this is sine squared divided by cosine. Do you see how we met in the middle? So if I can work one side to this and the other side to this, then what I can do is go backwards. And so since I had divided out both of these by cosine, what you do is you re-multiply by cosine, which is what I did up here. I multiplied top and bottom by cosine. So this is an idea. If you need to work one side and the other and you can make them meet, then what did you do and reverse it to get to the other, or reverse it and get to the other? Okay. Hope that helps on number 3. Let's go to number 5. So number 5 says tan squared times sine 2x equals 1 minus cosine 2x over cotangent of x. Okay. Now, my earlier statement about the double angles is true on both sides. I've got a sine 2x over here and I've got a cosine 2x over there. So I think what I'm going to do is I'm going to replace both and see if I can get to that spot and then work my way backwards. So I know tangent squared and then sine of 2x is 2 sine times cosine. And tangent squared is sine squared over cosine squared. And that's a 2 sine cosine. So if I can get myself, like one of these cosines will simplify out, if I can get this side to 2 sine cubed over cosine, then I can work my way backwards. Yeah? Or if I get it to here, I get it to there. So I am going to replace, let's see, 1 minus cosine 2x. Okay. Oh, it's actually right here. Well, anyway, I'll talk about that in a second. So 1 minus cosine 2x, again, I'm going to use my power reducing. 1 minus cosine 2x is 2 sine squared. So this is for me working right to left now. So this is 2 cosine squared. It's 2 sine squared. 1 minus cosine 2x. Okay. So 2 sine squared. And I'm going to go ahead and bring this up. This is dividing by a cotangent, the same thing as multiplying by a tangent. Cool? So then I've got 2 sine squared, and then tangent is sine over cosine. And there we are. I've got 2 sine cubed over cosine. Okay. So what I'm going to do is I'm going to multiply top and bottom by cosine, and the reason why I know to do that is because in order to get from here to there, I had to cancel out a cosine from top and bottom. So I'm going to do the reverse. I'm going to multiply by a cosine on the top and bottom, and And the reason, another clue that I need to do this is because I need a tangent squared, which is sine squared over cosine squared, and I only had a single cosine in the denominator. So I have 2 sine cubed times cosine over cosine squared. Now I'm going to split up my sine cubed. I'm going to say 2 sine times sine squared times cosine over cosine squared. And then I'm going to recognize that that's tangent, and that 2 times sine times cosine is a sine 2x. And, oh, sorry, that was a tangent squared. And multiplication is commutative, so I have got there. Okay? Now, what if I were working this side, and I were just working this side? Then I could say, okay, I know I need to get to 1 minus cosine 2x, right? So, what I can do is I can recognize that that is in sine squared. So I think what I would do is I would say, well, 2 sine times sine squared over cosine. Then I think I would say, well, this right here is tangent, so 2 tangent, and sine squared is the fraction 1 minus cosine 2x over 2. So 1 minus cosine 2x all divided by 2. Then I would see that these 2's go away, and I would be left with tangent times 1 minus cosine 2x, and remember that a tangent in the numerator is the same thing as a cotangent in the denominator, and I have gotten to the right hand side. So this is working purely left to right. Okay, let's go to number 7. So number 7 says cosecant plus cotangent squared equals cosine squared plus sine over sine squared. Interesting. Okay. Well, I think all I gotta do is split up the fraction. So I noticed that over here I've got cosecant, which is 1 over sine, and over here I've got cosine squared over sine squared. Well, that's, I mean, I have that right here. So what I'm going to do is I'm going to divide each of these by the denominator, cosine squared. I'm going to split up the fraction. So cosine squared over sine squared plus sine over sine squared. This is cotangent squared. This is 1 over sine, but 1 over sine is cosecant. And we're good. Okay. What if I had decided to work the nuts right to left? What if I were trying to go left to right? So if I were trying to go left to right, then I would have said, okay, cosecant is 1 over sine, cotangent is cosine squared over sine squared. Then I would have done a common denominator, multiplied this fraction by sine on top and bottom, and said sine plus cosine squared over the common denominator sine squared, and we're done. Cool. Okay, so that one is just a simple common denominator and such. Okay, then there is number 9. So number 9, I think I have enough space, says cosecant squared minus 1 over cosine equals secant over tan squared. Okay. I think I want to work, honestly, other side, but cosecant squared minus 1. That's a Pythagorean identity, right? So 1 plus cotangent squared equals cosecant squared. So that means cosecant squared minus 1 would equal cotangent squared. Yeah? So cosecant squared minus 1 equals cotangent squared. So I'm going to replace cosecant squared minus 1 with cotangent squared over cosine. Now, I know that the reciprocal of cosine is secant, so I'm going to move the cosine up to the top as secant, and I know that cotangent in the, oh, you can't even see that. And I know that cotangent squared in the numerator is the same thing as tangent squared in the denominator. And we're good. There you go. Okay, could I have worked that a little bit differently? Yeah, sure. So this one right here, I could have said 1 over sine squared minus 1 over cosine over 1. Done a common denominator and said multiply top and bottom by sine squared, and said 1 minus sine squared over sine squared times the reciprocal of cosine over 1, which is 1 over cosine, and said, okay, 1 minus sine squared over sine squared times cosine, but then 1 minus sine squared is the Pythagorean. 1 minus sine squared is cosine squared, so I would have said cosine squared. And then I would have said, well, cosine squared over sine squared is cotangent squared, and then divided by cosine, but this in the denominator is tangent squared, and this in the numerator is secant, and then we're back to our answer. Okay. So there's the odds, and if you need any help on the evens, feel free to contact me individually, okay? And sorry about the wait.